Hello guys, we are back with our next lecture. In this lecture, let us go through the next topic. So in the last lecture, we discussed about concurrency and what are the different problems which could arise when we are trying to run multiple transactions parallelly, right? Yes. So basically, whenever we are trying to run multiple transactions parallelly, so these thing is called as a scheduler, guys. Okay, so when two or more transactions execute together or one after the other, then they can be bundled into a higher unit of execution, which is called as a scheduler. So this is a scheduler, and inside scheduler we are going to have multiple transactions. So now you understood, right? The terminology is scheduler. Okay, yes. So this is a small example. So these are the two transactions, I1 I11, I12, I21, I22. So I1 first line, I1 second line, I2 first line, I2 second line. So remember guys, so whenever we are trying to convert this into scheduler, you are not going to write directly scheduler here. So the thing what you do is you are going to mix these things in such a way that in a single line there will be only single instruction. Like after I11, I21 will execute. After I21, I12 will execute. After I12, I22 will execute. So this is the order, right? So in which order they are executing. So if you write that, that is nothing but a scheduler, guys. Got it? Yes. And there are few important things. So assume that this is a block of code. So assume that this is the first line, this is the second line. So if you are executing a code, so this order should be same, right? After one only two should be there. So I12, I11 is a wrong order, right? Yes. So now your question will be, okay, so then why did I arrange only in this way? There are various ways, right? You are correct. So these are all the ways, guys. So I took the same example and I have written all the different combinations here, guys. So this is the example, right? So T1, T2, I11, I12, I21, I22. So the only rules are I12 should be I12 should be after I11, I22 should be after I21. So first I started taking the combinations. So first I executed T1, then I executed T2. So in the second time, in the second type, I executed T2 first and then T1. This is the second type. So in the next I intermixed them. In the next I intermixed from the opposite side. In the next I kept the I2 in between. In the next I kept I1 in between. So these are all the possible 6 different types. Got it? Yes. So these are all the possible combinations, right? Yes. So I think there are few combinations missing, few students will be saying, but those combinations are going to violate these conditions, right? So in that the order will change, right? Yes. So these are all the 6 combinations which are approved to be schedulers, right? So each of these is a scheduler. Got it? Yes. So now I hope everyone got a clear idea, right? So what exactly is the term scheduler and how you can know how many are there? Okay. Yes. I'll be saying you a trick also, so like how to directly calculate this. So don't worry. Okay. Yes. Okay. So let us continue. Okay. So all these schedulers, all these 6 schedulers are divided into 2 categories, guys. So the first category is a non-serial. The second category is a serial or serial and non-serial. Okay. Yes. So now your question will be, what is a serial and what is a non-serial? So in simple words, serial is nothing but if I start executing a particular transaction, I will complete that transaction and only then I will move to the next transaction. So that is nothing but a serial. When it comes to non-serial, I am going to mix those 2 transactions and I will run parallelly or in any order. So that is nothing but a non-serial. Got it? Yes. So now observe and let me know what are serial and what are non-serial, guys. So I think everyone has understood, right? Yes. So this is a serial, right? Because T1 executed first, then T2. This is also serial because T2 executed first, then T1. This is a non-serial because they are mixing up. This is a non-serial because they are mixing up. This is a non-serial because they are mixing up. This is a non-serial because they are mixing up. So indirectly we are having 4 non-serial and 2 serial, right? Yes. So now I hope everyone is getting at least some basic idea, right? At least, right? Yes. Okay. So now your question will be, okay, so we understood the concept, but in the examination, if the examiner wantedly gives more transactions here, like more instructions inside the transaction, then are we going to draw these diagrams and should we understand it, or is there any kind of formula or is there any kind of trick? The answer is yes. So there is a particular generalized formula, guys. So assume in this way. So assume that there are B transactions. So T1, T2, T3, T4, T5 and so on up to TB. Okay, TB. or tn also you can assume, but here I assumed the n as the number of transactions, so that's the reason why I changed it to b. Okay, yes, with n1, n2, n3, n4 and so on up to nb transactions in each of them, right? So here what is the case? Here we are having two transactions with the 2 in each, so here 2, right? Yes, so the formula is, it's really simple guys. So n1 plus n2 plus n3 plus and so on up to nb factorial divided by n1 factorial into n2 factorial and so on up to nb factorial. So let us apply this to our example. So it is nothing but 2 plus 2. Okay, so n1 and n2 are nothing but 2 and 2 in our question, in our example, right? Yes, okay, whole factorial divided by 2 factorial into 2 factorial. That is nothing but 4 factorial divided by 4. That is nothing but 4 into 3 into 2 into 1 divided by 4. That is nothing but 3 into 2, that is a 6. So if you recall, that is what we got, right? Yes. So that is the simple formula, right? So now you understood, right? So how exactly we are calculating this total? Yes. So what about serial? So now you will be like, okay, so we understood this about total, so we can calculate the total, but what if in the examination he gives only non-serial? If he asks, what if he asks only serial? Yes, we are having tricks for that also. So for serial, it is nothing but b factorial. What is b, guys? B is nothing but the number of transactions. So in our example, the number of transactions are also 2. So it is a 2 factorial, that is nothing but 2. So 2 are serial. Yes, so now this is a funny thing. So how we can calculate non-serial, guys? It is nothing but total minus serial, right? So 6 minus 2 is nothing but 4. So that is nothing but non-serial. Got it? Yes. So that is nothing but the last formula. So this is the generalized formula for serial and non-serial, guys. So it's a quite easy thing, right? Yes. So now I hope everyone will not even try to solve this 2, right? And they will try to use these formulas and they can solve it, right? Yes. So I hope everyone got a clear idea, right? Yes. So now let us go through the definition so that you can remember them, right? Yes. Okay. So a serial scheduler. So a serial scheduler consists of a sequence of instructions belonging to different transactions. When instructions belong to one singular transaction appear together, so they are going to appear together. Okay. So before completing execution of one transaction, other transaction cannot be solved. So if you start with the T1 should be done completely, only then go to T2. So that is the concept of serial. When it comes to non-serial, it is opposite of that, which do not satisfy the serial or non-serial concurrent execution of these steps. Got it? Yes. So this is the serial example. This is the non-serial example. Got it? Yes. So these topics are really easy, guys. The only thing is you should remember these things. So what is a serial? What is a non-serial? Because these serial and non-serial terms will be used in our future topics. Okay? Yes. And that is the main reason why I am dedicating each and every video for some particular small topics also. And I'm explaining in detail also, right? Yes. Okay. So now I hope everyone got a clear idea with respect to the serial and non-serial concept. So in the next lecture, we'll be discussing about conflict equivalent, and we will also discuss about conflict serializable, guys. So these two terminologies are completely new for us. So in the next lecture, we'll be discussing about them in detail, guys. So in these definitions, you will observe the words serial and non-serial, guys. Okay. Yes. So in the next lecture, let us discuss about these things. Okay. Conflict serializable and conflict equivalence. Okay. Yes. So let us meet in the next lecture. Thank you. Thanks for watching. Like, share and subscribe for more awesome videos like this. Thank you.